Hello, and this is my presentation for this week's interactive concept presentation of kinetic sand. So the main concept we were exploring this week was the idea of polymerization in organic chemistry. And this experiment is specifically looking at polymerization, and polymerization is a reaction where monomers react by moving electrons from double to single bonds to form long chains of polymers and 3D objects. So examples of polymers would be polyethylene, things used to make like plastics and bottles, and polypropylene, which is used to make kitchenware and appliances, things like that. Here I kind of had added a little bit about the different types of polymers, and I think that the kinetic sand experiment today that we're observing is more of an addition polymer where the organic molecules are sticking together to form long chains through alkanes or single bonds, whereas the condensation polymers, those reactions form water as a byproduct, and then the electrical conduction polymers form triple bonds like alkanes. So I think today this experiment we're specifically looking at the addition polymers. So I used, I went with what the video showed on our Blackboard webpage, and I kind of followed her instructions. So I used dish soap, cornstarch, and sand. We got plain sand from Lowe's, and according to the SDS sheet that I found on the website, this contains silica, and but also the cornstarch and the dish soap is what allows us to see the kinetic sand form. But anyways, I also have some food dye here, but I didn't end up using that because it was just, I thought it would be too messy. The experiment was messier than I thought it was going to be. So this is my first attempt at this experiment. So I first used the water dish soap in combination, where I first mixed the sand and the cornstarch together. And so I just added in the water and dish soap and then combined a little at a time to see how it would react. So as I was mixing, I was seeing that the sand just kind of looked more like wet sand, not really, I didn't see it binding together too much. So here I found it was sticking to me a lot, so I really didn't add much of the water. And then you can see here the consistency just, again, looks like wet, mushy sand, not so much kinetic sand at all. So then going back, I did a second round of the experiment. I used a different method that was also shown in the video, where you combine cornstarch with the dish soap and turn it into a paste before I don't know if you can also see here, but even though I did use play sand, I did find that there was a lot of larger rocks, so I wish that I had sifted it or could have gotten some finer sand. So this is kind of how this turned out in the end. So I definitely, here it's more of a ball, but when I pulled it apart, it definitely had, like, it kind of fell apart. The consistency of kinetic sand that I had played with before. So I was pleasantly happy with that, how that one turned out. In hindsight, I probably would have tried to make the experiment with the glue. She did try that before. Okay, so how kinetic sand is made? So found that it's 98% sand, 2% polymer, cornstarch, and water dish soap in this experiment. Silicone is a compound containing oxygen, silicon, and a long chain of repeating units. So that was part of the sand as well, and the polymer helped that bind the silicone together. So kinetic sand works as a non-Newtonian fluid called dilant, and the silicoated sand allows the particles to stick together but not to other surfaces. So the dilant material in this experiment would have been the cornstarch and the dish soap, as it increases the viscosity of the sand under stress. So overall, I thought this experiment was a really fun way to see how polymers work and able to see how versatile silicone polymers can be. So overall, it was a very fun experiment.